Yes, good evening all. So hope my voice is audible to everyone. Is it audible, guys? So see, I've started 10 minutes early. So as usual, I've started with the lab setup. Uh, yes, last class also I've done the same thing. So initially, guys, so once you're opening your virtual lab, you have to open terminals, three terminals. See, this is the setup you are going to see in your virtual lab. You have to click on start button. See, previous to this, it was showing start button. You click on start button. So it will take uh, some time and then it will show this buttons. Okay. So then after that, you have to click on connect button. So once you're clicking on connect button, it will show one more window with web console. You click on web console. So then it will open this window. Okay. So on top of this window, you have terminal. You just click on terminal. So it will open terminal. So initially what you have to do, let me show you. So initially you have to check the IP address of all the machines. See, you are opening multi-node system. So this is your master. This is node 1. This is node 2. So here, see, you can observe. So this is your master, dummy user master. So once you are typing host name space minus capital I. So it will show you the IP address. The same IP address you have to copy for all three machines and you paste in some other place. And then once everything is done, you open this /etc/host file. And inside this, see, it is asking for the password. Password is cloud. For all, it is cloud, guys. So here you have to replace. Okay, here you have to replace the IP address. So since IP address is dynamic, so every time when you're going to open your system, you have to do this setup every time. Okay. So once everything is done, so come out of it. So after coming out of it, you can ping the machines. So I'm trying to ping Hadoop. Okay, slave one. So I'm checking with slave one whether it is connected or not. So once you are pinging, so immediately it will start showing all these messages, packet transformation messages. See, it is connected. Since it is connected, it's showing a message. Control C to come out of it. Maybe yes, electrical students will be knowing about this, electronic students. And next ping, and then you can check with the second system also, Hadoop slave 2. The second system name is Hadoop slave 2. You can click on Hadoop slave 2 to check whether it is connected or not. See, look at here. This is also connected. So every setup is done. So once everything is done, then what you have to do, as I told, you have to start with daemons. Okay. So this is the command to start all the daemons. See, start -all.sh to open HDFS, guys. So it will list all the daemons. So once everything is done, then type JPS. So here, look at here. So this is your master node. So in master node, it is showing name node, resource manager, and secondary name node. So once you are typing the same thing on your slave one, it will show data node, name manager, and even it is going to show same thing on your slave two also. So here it is showing data node, name node. Okay, name node manager, sorry. Okay, so once everything is working fine, then you can work with your code, guys. So hope this is clear to everyone. So anybody is tried? Anybody is tried? Anybody is installed the software on your own system? And have you tried with all these things? Can I get quick confirmation on chat box? Anybody tried, guys? No? Sir, I have installed Hadoop in local. Okay, Upadhyay. Okay, so what about others? Guys, actually, we are one step ahead to our midterm examination, but still, the attendance is very less. I don't know why. Upadhyay, is it working fine? Is it working fine? Yes. Okay. Have you tried with MapReduce programming? Guys, actually, have you checked in your Tuxila? So in your Tuxila, I have posted all the lab program means not all the lab programs. So few lab programs. See, you just click on your Tuxila. So in Tuxila, you have a separate folder, experiential learning. See here, today also I have uploaded all the programs. Okay, you just click on this. See, this is HDFS commands, and this is one program on MapReduce. So all the steps I have given here, guys. So each and every steps I have given, program also I have given. So only the thing is you have to test the code. That's it. And in module 7 also, see, last class I have told you, right? So we have left few examples. See, all the working examples I have uploaded here. You just extract this file and start working on that. Okay. So even your virtual machine is working fine. You can use your virtual machine to work on that. So is it okay, guys? Can you all try with this? Can you all try with this, guys? So before examination. So I'm including all this concept in your examinations, guys. That's why I'm asking you to work with your system. Okay, you have to try Hadoop HDFS commands, MapReduce coding, everything. So is this clear to everyone? Is this clear to everyone? Yes. Yes, Sally. Thank you. Okay, fine. So then, yes, guys, without wasting time, let us start today's session. Yeah. So last class, we have left with a few concepts, right? Once again, guys, let me connect to me through my mobile. Second, guys. So it is chat box. Yes, it is here. So do we have class today? What is this message? Do we have class today means what? Okay, guys. Yes. Again, once again, a warm welcome to you all of to what each session. Once again, guys. So last class we have left with few topics, right? So today I'm starting with the same. Okay. So we are continuing our journey of session 7. Guys, as usual. So last class we have I have told you, right? Guys, this program, example 1, I was talking about this example 1. So this example is already executed and the same is uploaded on your Taxila. Okay, not only this program, example 2 also min-max program, and example 3 also custom partitions, and one more n keys given key value pair. This also I have uploaded, and using combiner also maybe I have uploaded. Yes, I have uploaded this also, and this example I have given you as a homework problem. So this is only one page program. You just go through this program, you will understand by yourself. Okay. All 5 programs I have executed and I have uploaded on your Taxila. So go to home and try with all the examples. Okay. Yes, guys, now we are moving into the very important concept that is called as Hadoop streaming. So can anyone tell? Already we have discussed about Hadoop streaming. So where we have discussed about Hadoop streaming, can anyone tell me? What do you mean by Hadoop streaming? Why it is useful? Any answers from your end? Why it is useful, guys? Hadoop streaming.
I am not getting any responses. Hadoop streaming is the utility within the Apache Hadoop framework that enables users to write MapReduce program. Of course, yes. Of course, yes, sir. But yes, other than that, we have one more benefit. Your answer is perfectly correct, but we have one more benefit of using this. What is that? There is a delay in getting messages here, guys. So memory filtering, no, that is not the answer. So even move large amount of data is also not correct answer. That is also not correct answers. Guys, can you all tell me? Yes, shuffle and sort, it is inbuilt. Okay, that is already there in your system. That is also not correct answer. Integration of existing string. Okay, that is the perfect answer. But I'm looking for one more answer. Guys, can you all tell me by using which language I have written my code? By using which language I have written my code? So I've used Python, right? I have not used Java. Okay, I have used Python. But Hadoop is written in which language? Hadoop is developed or implemented in Java language, right? And actually, in your Hadoop system, you have many jar files. Okay, so if you are a Python or C++ developer and you don't want to write your MapReduce program in Java, the good news is you don't have to. Okay, good news is you don't have to. Hadoop streaming is the utility that allows you to create and run your MapReduce job with any executable, guys, or script as a what mapper and our reducer actually. Is it interesting? Is it interesting? That is the main purpose of using this MapReduce code, guys. So this is one of the what powerful feature because it opens up the Hadoop ecosystem to the wider range of developers and programming languages. Okay, it works by using STD in and STD out. So both are what? Streamings, right? Input output streaming, right? The Hadoop framework feeds the input data to your script standard input and your script output key value pair. So to its standard output. Okay. The framework then reads this output and perform the shuffling and also sorting operation. Guys, here the Hadoop streaming handles all the boilerplates code for you people. Okay, you just need to provide the logic for your mapper code, logic for your reducer task. That's it. By using your favorite language. Okay, the framework creates the MapReduce task and runs your executables and monitors their progress. Is it not interesting, guys? Correct, no? And one more thing, guys, even you can override the default configurations such as input-output format, partitioners, combiners, and your own customer implementations. So there is also a special aggregator package that can use as a what reducer. So it provides built-in foundations for common aggregations like max, min, count, and sum. So which can simplify your code even further. So this is the great feature for prototyping and for teams that use different languages. So it allows you to leverage the power of Hadoop distributed processing without being tied down to Java language. So now we all understood, right? What is the main purpose of using this? Yes or no? Everyone understood? Okay, that is the main purpose, guys. And all of you look at here, guys. Everything I have explained you here. So this is the example I have taken here to showcase. Okay, this is one beautiful real world example I've taken using Hadoop streaming to solve the problem. The task is to count the number of sales record, okay, for each date from your CSV file. Okay, the file has the date column and we want to know how many transactions happened on each day. So here, what command we are going to give, guys. See, look at here. Look at everyone. The very first line. So this command we have already used, right? Hadoop jar. See, this is the path for your streaming file. Hadoop streaming 2.10. So this number is going to vary from version to version. Okay, right now we are using 3 point something. So here they have taken 2 point something. So this is the jar file address. So we are going to take initially. Okay, so this is the what command to launch the streaming utility. Try to understand this streaming utility. And next to that, look at here, guys, -d mapped mapred dot reduce dot task is equal to 1. So this is the command we have taken here, right? So this sets the number of reducer to 1. Okay, so which makes sense because we need to get our total count for each date. So we need only one reducer. So I can fix the number of reducers also. Okay, and next to that, you can observe here, you have input. So this is the input file I have given here. What is that? Input sales jan 2009.csv. Okay, so this specifies the input file on HDFS and output directory for the result. See, look at here. So this is output directory for the result. Output/out. And next to that, you can observe here, we have mapper, test.py, reducer, aggregate function. See here. So inbuilt function we have used here. Correct, no? So what is this reducer aggregate? So here we are using the inbuilt aggregate reducer function. Okay, it is a generic reducer that can handle various aggregation functions. And finally, you can see here. So file ./test.py. What is this ./test.py? So this is a very important part, right? It tells the Hadoop to copy our test.py script to all the worker nodes so that the mapper can run it. Okay, you just look at here, guys. You just look at here. Below that, see, we have a script. So script for your test.py. So this is the complete script for your test.py. Okay. So this script, see, what is the job of this script? The script job is to read lines from stdin. So it will read the value from standard input and extract the date from the sales record and output a key value pair. So key value pair would be date comma 1. So this would be the, okay, here it is mentioned. So date comma 1 to what standard output. Okay, so this is a classic word count program, guys. But for, see, this is the classic word count program. And aggregate, what aggregate is going to do? See, I have not written reducer code here. I have written only mapper code. What about a reducer? See, reducer, we have taken inbuilt functions here, correct? No? So this aggregate reducer will then automatically sum up all the ones for each date, and the output will be the total number of records for each date. So which is exactly what we wanted. So this example highlights how simple it is to what use Hadoop streaming. You don't need to write complex Java code, guys. You can use a simple script that reads from std in and writes to std out. So hope everyone are understanding this. And now, see, we have covered the entire concept Hadoop and reduce. So if you have any doubt on this, you can ask me, guys. I don't know why I'm not getting messages in my mobile. So still there is a delay on getting messages. Let me see. Anybody's put any messages or not. So have you all understood, guys? So how to run the code? Even last class I have shown you, right? So you just go to the previous class. In first 10 minutes, I have compiled the word count program. Okay, that see the same streaming command I have used to what compile the Python code. So if you have any doubt, please do ask me, guys. Otherwise, we will move to yarn part. So now we have done with MapReduce part. So now we are jumping to yarn part. So do you have any doubts? So do you have any doubts? Quickly, guys. So please do reply on chat box, guys. So once you have no doubts, please do reply me on chat box. No doubts? Okay. Sir, if I am running JPS only showing this JPS, then it is not installed properly, Aditya. Actually, where you are running this command, where you are executing this JPS, on master node or on a slave node? Where exactly you are facing this problem, Aditya? On slave node. You try it in master node. So you try it in master node. What it is doing on master node, what it is showing on master node. So data node, it will show only on slave node. Along with that, it has to show one more, that is node manager, but it is not showing. It is not showing means. So there is a mistake at the time of installation. Okay. Yes. So yes, guys, no doubts on streaming part, right? So now, yes, guys, let us jump to the very important part that is called as yarn. Guys, this is Hadoop 2 architecture. Okay. So this is comes under yet another resource negotiator. So we all know, right? This is the critical part of the modern Hadoop ecosystem. And yarn is what makes Hadoop is a general purpose data processing platform, not just a batch processing system. So before yarn, Hadoop was primarily for MapReduce. But now with yarn, other frameworks like Spark, Flink, Impala also run on the same cluster and share resources efficiently. So this concept is called as multi-tenancy. Okay, multi-tenancy. Try to understand this. Okay, multi-tenancy, and it is a what? Game changer, guys. It is a game changer. Okay, so over the next few minutes, so I'm going to discuss on only this, guys. Okay, so let us start with the very first slide. So here we are talking about Hadoop 2 architecture. Guys, this slide gives us high-level overview of the Hadoop 2 architecture. So which is a what? Master slave architecture. Okay, so it shows how the different components fits together. So remember in our last session, we talked about Hadoop distributed file system, right? That is HDFS, and its components, name node, data node. So everything we have discussed, right? So now we are adding the what? Now we are adding the compute and resource management layer to this picture. Okay. So on the master node, you have, look at here, this is your master node. On master node, you have name node. So already I've told you the responsibility of name node, right? So it is responsible for the file system metadata. And next to that, you can observe here. So we have resource manager. Okay. So which is the central authority for resource allocation. And one more thing, guys, on each slave node, you have data node. Look at here. So on each slave node, you have data node. Correct? No? This is data node. And which stores the actual data blocks. And along with that, we have one more that is called as node manager. Okay, so which is responsible for managing resources and running tasks on this specific node. Okay, the node manager and data node. So these two are communicate with the master node to get their instructions and report their status. And one more thing you have to notice here, guys. You have to notice one thing. So map and reduce. See, look at here. So we have map and reduce component. So it is showing, right? So it is now shown as task running within the slave node. So this is the key change from Hadoop 1.0 to Hadoop 2 actually. Okay, in Hadoop 1, the resource management and task executions were tightly coupled. Tightly coupled in job tracker and also task tracker. Okay, but with Hadoop 2, so this is decoupled. The resource manager is now solely responsible for resource scheduling. So this will take care of scheduling part. And also And also, guys, the tasks themselves run in container managed by the node manager. Guys, this decoupling is a huge deal. It allows Yarn to manage not just MapReduce, but also any type of distribution application is to be what handled by this. So it is the reason why other frameworks can now run on Hadoop system. So hope everyone understood this. So is this clear to everyone? So till here everything is clear. Shall I get clear message in chat box? Shall I get clear message in chat box? Where I'm getting messages. I'm not getting messages here. Okay, fine. So now, guys, so we are moving into the next slide. See, look at here. Changes from Hadoop 1. Why Yarn? This is the question, right? Okay, guys, this slide really gets to the core of why Yarn was created. In the old Hadoop 1.0 architecture, the job tracker on the master node was a central point of failure and a major bottleneck. Correct? No? Yes or no, guys? So the job tracker was responsible for both resource management and job scheduling. The task tracker on the slave node would periodically send heartbeats to the job tracker. Understanding my point, guys? So we look at here. We have so many task trackers here. Okay. See, this will be always present on your slave machines. So this would be what periodically send heartbeats to the job tracker. Look at here. You can observe here. And the job tracker would then give them new tasks to run. This tightly coupled architecture had fewer major limitations. So what are those limitations? The very first point is single point of failure. That is one disadvantage of using this Hadoop 1.0. And second one is scalability issue, guys. So the job tracker had to keep track of what? Every task on every node. And this became a what bottleneck as the cluster size grew. And there is no multi-tenancy. So in this what Hadoop 1.0, there is no multi-tenancy. Okay, so these are the three disadvantages of using this actually. But guys, Yarn. See, now we are introducing new one that is called as Yarn. So Yarn was created to solve all these problems. The core idea was to decouple the resource management layer from the MapReduce processing layer. So guys, Yarn is now dedicated resource manager for the cluster. Okay, this is the dedicated resource manager for the cluster. Understanding my point, guys? So the result is a more scalable and flexible architecture. And one more thing, Yarn enables multiple applications to share the same cluster without requiring separate cluster for performance isolation. So it can also run Hadoop 1.0 jobs. So it's backend compatible for each and everything. So this decoupling of resource management and data processing is the most important architectural change in Hadoop 2. Okay, Hadoop 2. And it is why Hadoop is now general purpose platform and now just niche batch word processing system. Okay, so where does Yarn fit in Hadoop? That question you can ask me, right? Guys, this slide will give you what clear picture on where does Yarn fit in Hadoop. Understanding my point, guys? So at the bottom layer, you just look at the bottom layer. So we have HDFS, correct? No, bottom layer we have HDFS. We know the purpose of using this, right? So this is our reliable fault tolerant storage area. Okay, and sitting on top of HDFS is the Yarn. Look at here. So where is yarn is placed here. See, and also in bracket, I have mentioned it as resource management layer. So this is the brain of cluster system. Okay, yarn's job is to manage the compute resources and allocate them to various applications. And it is the foundation on which all other processing frameworks run. And at the top of that, what do we have, guys? So we have data processing. So we have data processing frameworks, and along with that, we have MapReduce. Okay, guys, MapReduce and other frameworks like Spark, Flink, Storm, anything I can install on top of this yarn. The beauty of this architecture is that all these different framework can run on the same cluster. So using yarn to get the resources they need and HDFS to store their data. And this layered approach gives us some huge benefit, guys. What and all huge benefit we are going to get here? The very first huge benefit we are going to get is scalability. Guys, you cannot guess this, guys. See here, I have mentioned the very first point. How many nodes are connected here? Guys, yarn has been tested on the cluster with over 10,000, not 1,000, guys, not 1,000, 10,000 nodes. So showing its ability to scale to massive sizes. And the second benefit of using this is compatibility. Guys, it's compatibility with both old and new processing engines. And one more very, very important thing is dynamic utilization. Dynamic cluster utilization. The cluster resources can be dynamically allocated to different applications based on the demand. So if a Spark job needs more memory, yarn can give it, guys, as long as it is available. And finally, I have told you, right, this is one of the beautiful benefit of using this, that is multi-tenancy. Multiple teams are different types of applications. You can run batch processing, you can run graph processing, stream processing, interactive processing, whatever you want. See, all these can share the same cluster. Because of that reason, so it is called as multi-tenancy. And this modular design is what has made Hadoop a central player in the big data ecosystem. And it is the key architectural shift that every big data professionals must understand. Okay, so look at the component of yarn, guys. These are the different components of yarn. So I have explained this by using 2 to 3 slides. Okay, so this is the main architectural components of yarn, guys. So how they interact with each other? The very first thing is, look at here. Look at the very first point what I have mentioned here. The very first point I have mentioned here is client. Okay, what is client, guys? So client is the program that the user runs to submit a job to the cluster. Master component of the yarn. Okay, so it is a single daemon running on the master node. Try to understand this. Okay, so its key role is to manage and schedule resources across the entire cluster. And it has two main components, guys. So these are the two main components. One is scheduler, another one is app manager. What is the role of scheduler? Already I've told you, right? So this is the core functions of the core function of what? Your resource manager actually. So it is responsible for allocating resources to different applications based on the various policies. So which we will discuss later, guys. Policy and all we will discuss later. Okay, based on some policies, we are going to distribute resources, and it decides which job gets what resources. That is the main job of this scheduler. And along with that, we have one more that is called as application manager, or we can call it as app manager. Okay, so this component is responsible for managing the life cycle of the application. What do you mean by that life cycle? Guys, it accepts a job request from the client, and it is responsible for setting up a special container to run the application master for each job on a slave node. If the application master fails, the application manager will restart again. Okay, so next to that, what do we have, guys? One more component we have, that is called as node manager. So node manager is the agent that runs on each slave node. It takes care of all the local resource managements and workflow. That already I've explained you, right? Guys, this includes, look at here. So this include, what it is including, guys? So this is including what? This include creating, look at here, creating, killing container, monitoring usage, and also log management. So all these log files are managing by this node manager. And you can think of the what resource manager as the central traffic cop and the node manager as the local police officer on each street. So very simple example I've given to understand what exactly resource manager and also node manager. And next to that, look at here, guys. So we are talking more about application master. Okay, so which is again called as app master. Okay, look at here. You can observe here. So here we have a app master. So this is a very important part of Yarn, guys. So for each submitted application, the resource manager sets up an application master inside a container on one of the slave node. Understanding my point, guys? For each and every job, you will be having separate application master. So inside the what container, that you should remember. And the application master is essentially the representative of the application in the cluster. So its job is to negotiate resources for its applications from the resource manager. So it is negotiating, guys. That is the main job of using this actually. And the application master is responsible for, look at here, I have mentioned each and every point. Negotiate resources from the resource manager. That is the very first point. And it will be what? Keep on sending periodic health and progress report to the resource manager. And third one is communicating with the node manager to launch the actual task. And the fourth one is, so client can even talk to the application master directly for application specific information. So these are the four responsibility of this application master. And finally, what do we have here? So finally, we have container. Guys, a container is a logical bundle of resources on a single node. It is a collection of resources, guys. That's it. So think of it as a what slice of node resources. So which is including CPU, memory, storage resources, so on and so forth. Understanding my point, guys? The application master, see, always the application master request for this container. Okay, from the what resource manager. And the node manager is responsible for creating this container and running the task inside the container. And the container, see here I have mentioned container launch context. In short form, we are going to call it as CLC. So this is the data structure. Okay, that specifies what the container should do. And it contains everything needed to launch the process, including the command line, environment variable, dependencies, and security tokens. So to summarize the interaction, the client submits a job and resource manager allocates a container for the application master. And the application master then negotiate for more container from the resource manager. And the node manager on the slave node launch the container and run the actual task. So this is what the entire concept I've explained you here, guys. So if you have any doubt on this, so please do ask me in chat box. I think each and every concept is crystal clear to everyone. Shall I get quick responses in chat box? Is this concept crystal clear to everyone? My pace of teaching is okay for you all, right? Am I going fast? So if I'm going fast, please do put a message in chat box, guys. You can stop me anytime. So is this clear to everyone? I'm not getting any responses. Thank you, Ajit. What about others? I have 25 students today. Yes. Am I making sense with each and every component of yarn, guys? Yes, thank you. Guys, now let us jump to the next topic. The next topic is explaining on yarn workflow. Look at the diagram. Each and every steps are clearly mentioned here. So I'm going to explain you each and every steps, guys. You all go through the steps. Okay, each steps are very, very important here. Okay, so what is the step one? Look at here. This is the step one. Guys, the process begins with client program. Okay, the user submit a job here. Understanding my point? See, user submitted job along with its specification to the resource manager. And these specifications might include things like the number of mappers, number of reducers, memory requirements, so on and so forth. Okay, so this is the very first step. And next to that, so we have second step. So what we are going to do in a second step? So what we are going to do in a second step, guys? So once we have received, so request from the client, see, look at here, you can observe here. So this is our second step. So here we have second step. The resource manager, okay, the resource manager receives the job submission and based on its scheduling policies, decides where to run jobs application master. So it finds a suitable slave node and asks the node manager on the node to start the container. Understanding my point, guys? So this is the second step we are going to follow here. Then what is the third step? Look at here. So we have mentioned here. So this is the third step. Guys, in third step, the node manager. Now the responsibility has to be what taken by node manager. The node manager on the chosen slave node launches the container and start the application master. Okay, start the application master inside this. That's all. So after choosing this, it will start the application master. And next we will jump to step 4. Guys, in step 4, once the application master is up and running, so it registers itself with the resource manager. It is like it is going to say, I am present, sir. Okay, so this is the very, very crucial step, guys. It allows the resource manager to know the application master is ready and active. And it also allows the client to communicate directly with the application master for status update. Look at it. So immediately it will give out connections from client to application master. Understanding my point, guys? Yes or no? See, it is allowing client to communicate directly with the application master for status update. Try to understand this. At this point, the application master is what? In charge of its application execution. It is the one that will now negotiate for the resource needed to run the actual map and reduce task. The resource manager's job is mostly done at this point, guys. But it continues to monitor the application master. That's it. Okay. So this part of the workflow is all about getting the application started. Okay. So let me see. Anybody is asked any question on this. So you're all understanding, right? So everyone are understanding. So first 3 steps are crystal clear. So what exactly we are running now? What exactly we are running now? We have started running what, guys? So we have started running application master, right? Then what next? What next? Huh? What next in step 5? See, look at here. You can observe here. So here we have step 5. As the application begins to execute, the application master now takes on the role of a resource negotiator. So who is the resource negotiator? So your node manager is a resource negotiator, right? Node manager or resource manager? Actual resource manager. Okay, it send request to the resource manager for container to run its map and reduce task. Okay, let me explain you with the examples, guys. See, for example, a map reduce application master might request 10 container for its mapper. Okay, let me take 10 container for its mapper. The resource manager using its scheduler. So it will find suitable nodes and allocate those containers to the application master. So an allocation is essentially a right to use a certain amount of resources on a specific node. That is the main job of what? Your application master at step 5. Is this clear? So that is there in next slide actually. See, look at here. Here we have. And what is there in step 6? So what we are going to do in step 6? See, once the container is allocated by this resource manager, the application master works with node manager. Understanding, guys? So application master works with node manager. Understanding? Okay, the application master provides node manager with the container launch context. Try to understand this. Container launch context. Okay, so which contains all the details needed to run the task, such as command to execute and the files to be used, everything. Okay, so after that, we will jump to the step 7. So after that, we will jump to the step 7. So what exactly we are doing in step 7? The application specific code inside the container. See, for example, mapping and also reducing task. So these two then communicate with the application master. Okay, so this is how the application master gets information about the progress and status of the task it launched. So this communication is done via an application specific protocol. So we have mentioned here application specific protocol. So this is very, very elegant design, guys. The resource manager does not need to know the details of every single task. It just needs to know about the what resource requirement of the application master. The application master, on the other hand, is an expert on its application and knows exactly how many resources it needs and how to manage all these tasks. Guys, this decoupling allows Yarn to be very generic and support a variety of applications without needing to change its core data. Understanding my point, guys? So let's complete our journey through Yarn workflow, guys. So now we are at the what last step. What is the last step? Last step is 8th step. Guys, here the client that submitted the job can communicate directly with the application master. So this is how the client gets update on the progress and status of its job. So this communication is done using an application specific protocol. See, for example, we will be having map reduce client. Okay, so this map reduce client can ask its application master for a report on how many mappers and reducers have completed. Understanding my point, guys? So this is to be what happened in step 8. Then what is happening at last step? What is happening at last step, guys? At last step, once the application completes, so either successfully or with a failure, the application master does a final check in the resource manager. So it deregister itself and the resource manager cleans up all the resources it had allocated to its application. And finally, guys, the application master then shuts itself down. Okay, the container that were allocated for the job are now free and it can be what proposed for the new applications. Guys, this complete the what full cycle of Yarn job. Okay, you can see how the different components work together in a coordinated fashion. The resource manager is the cluster level scheduler. The node manager are the what? per node agents. And the application master is the application specific manager. Guys, this distributed two-level scheduling mechanism is what makes the yarn so scalable and also flexible. It is a key reason why Hadoop has evolved from a single-use batch processing system to multi-purpose big data platform. So make a note of this workflow, guys. So this workflow is very, very important for your examination. Understanding my point, guys? So if you have any doubt on this, you can ask me, guys. Otherwise, I will move forward with application master. So shall I move forward with application master? So I have to give you more information on application master. Shall I forward, guys? Shall you move forward? Shall I move forward? Yes. Okay. Thank you, guys. Okay. More about application master. You can look at here, guys. So I want to spend a little more time on application master because it is a fundamental shift from Hadoop 1.0. And think of the what application master as a framework specific library. Framework specific library. When a map reduce job is submitted, the resource manager runs the what map reduce application master. Okay, if you submit a Spark job, it would run a Spark application master. The application master is responsible for all the application specific resource request and also task management. So this is the brilliant design choice, guys. So there are some reasons why it is brilliant design choice. The very first one is separation of concerns. The meaning of this is, so it separates the resource manager's job from the application's job. And also one more reason behind this is user specificity. The application master uses the user specific code. The resource manager needs to protect the what cluster from malicious or rogue applications. And the application master helps it to do that by serving as a what application representative. And third one is scalability. And fourth one is flexibility, guys. Okay. So how come flexibility? Guys, this design is what enables yarn to be used for multiple data processing engines. So it is a generic resource management layer that can support a variety of frameworks. So the application master is essentially the proxy for your applications in the cluster. Try to understand this. Okay, so it is the one that knows your application's needs and communicate them to the central scheduler. Understanding my point, guys? And here we have a job submission flow. You just try to understand this. So this diagram is completely giving you the job submission flow. Okay, look at the diagram, guys. This show different components and also how they interact with each other. The very first one is, what is the very first step, guys? Client to resource manager, correct? No? So this is the client node to resource manager. This is the first step. So what client is going to do here? The client submits a job to the resource manager. So this is the very first step. Okay. And the second step, what is the second step, guys? Resource manager to node manager. Look at here. Resource manager to node manager. So the resource manager then tells a node manager to launch a container for the application master. And next to that, application master to the resource manager. Correct? No? See, look at here. Application master to the resource manager again. What it is going to do, guys? What it is going to do? The application master, once launched, register with the resource manager and start negotiating for the resources. And next to that, application master to the node manager also. Look at here. Application master to the node manager also. So the application master then talks to the node manager to launch the actual task container. Actual task container. Okay. So next to that, we have task container to the application master again. Correct now? So the task container, what is the job of it, guys? The task containers run the map reduce task and reports their progress back to the application master. And finally, guys, at step 6, so client to application master, the client can get the status of job directly from the application master. Guys, this flow from submission to completion is a perfect example of decentralized control model. Okay, the resource manager is the central controller, but it delegates most of the application specific logic to the application master. So this is a very robust and scalable design. Guys, understanding this flow is crucial for troubleshooting and optimizing your jobs. Okay, so if a job is taking a long time, so you can now trace which step might be the bottleneck. See, for example, is the application master waiting for containers from the resource manager? Are the tasks in the container taking too much of time? So everything you can analyze once you have understood this diagram. That's all. Okay. And look at here, guys. So we have a topic on one more, that is YARN resource model. So we have a topic on YARN resource manager. What exactly is a resource in YARN? What exactly a resource in YARN, guys? Correct? No, very good question. No. So it is not just the number of nodes. A resource for an application is defined as the set of containers. Try to understand this. Set of containers. And each container in turns is defined by its resources. Am I right or wrong, guys? And you can observe here, a container has 3 main resource attributes. What are those? The very first one, so it will be having resource name. Okay, this refers to the what physical location, such as the what host name. Just now I've shown you, right, before starting my class, host name. Or you can take your rack name also, guys. And this is the what important for data locality. It is always better to run map task on the same node where the data block is stored. Try to remember this. And what is the second component of this? The second component of this is memory. So we know, right, what is memory? This is the amount of memory in megabytes. So you can configure the memory for map and reduce task using properties like map reduce map memory map. Here I have mentioned map reduce dot map memory dot map. Okay, and map reduce dot memory dot map also I can use here. And the next component is what, guys? Next component is CPU. So this refers to the number of virtual cores, guys. It is not physical cores. So virtual cores. You can set this for a what map and reduce that task using properties like, see here, we have a property. Map reduce map CPU V cores, map reduce dot CPU V cores. Okay. So in addition to these, so other resources like disk, network IO, okay, can also what be added over a time. Okay. The resource manager maintains a complete view of all the resources across all the nodes in the cluster. So this global view is essentially for it to make intelligent scheduling decisions. When a job is submitted, the resource manager knows exactly which nodes have available resources. Understanding my point, guys? The YARN resource model is very granular, guys. Once again, guys, it allows you to specify exactly how much CPU and how much memory your task need, and which leads to what better resource utilization and also performance. You are not just getting the whole machine, you are getting a slice of machine, guys. That you should remember. Okay, now look at the resource request. Okay, now look at the resource request. Guys, we know what container is, right? But how does an application master actually ask resource manager for one? So it does so through a what resource request. Correct? No? A resource request is a data structure with 4 key parts. What are those 4 key parts, guys? The very first one is resource name. So it can be what? Specific host name or rack name or wildcard. Okay, you can use wildcard also. You can use star. That is to indicate what any host will do. That is the meaning of that. Guys, The application master will usually request a specific host first for the data locality. If that fails, so it will request a rack. And again, if that fails, it will request any host. Try to understand this. And what is there in the next one? Next one is priority. Next one is priority, right? So this is the priority level for the request. So it is used to schedule, it is used for the what scheduler and prioritize resource allocations within the application. See, for example, a map task might have what higher priority than the reducer what task actually. That you should understand. Okay. And what is the third one? Resource requirement. The third one is resource requirement. Correct? No. So this is the actual amount of resource needed, like CPU, memory, so on and so forth. And finally, we have number of containers. So this is the number of containers the application master wants with the above specification. Guys, the very interesting thing is when the resource manager successfully allocates a container, it gives the application masters a right to use a certain amount of resources on this specific node. Understanding my point, guys? This right. So this right is essentially a security token. And application master then present this right to the node manager. See the beauty of what using this, guys. That too node manager on the what specific host. And the node manager verifies the token and launches the container. Is it not beauty, guys? So this security model ensures that an application master cannot launch a container on the node without a valid allocations from the resource manager. And this is very secure and robust model. So it ensures that the client cluster is used fairly and that applications cannot steal resources from each other. So how is this, guys? Is this beautiful? Is this beautiful, guys? So if it is beautiful, can you all type beautiful on chat box? So now you're all making sense, right? You're all understanding, right? So why we have to go with Hadoop architecture? So it is more secured, guys. That is one reason why we have to use this Hadoop architecture. So how many of them will agree with my point? Can you all raise your hands? So if you are agreeing with my point, please do raise your hands, guys. Yes, thank you all. Now quickly I will go through the next slide. See, next slide, what can be launched in a container? Guys, we know that container is a bundle of resources, but what can you actually run inside of it? The Yarn container launch specification API is designed to be platform agnostic. The meaning of this is you can run pretty much of any processes in the container regardless of the what operating system. The specification contains the following, guys. So it will be containing command line. So this is exact command to launch the what process within the container. See, for mapper job, it would be the what command to launch map, and for reducer, we are going to use reduce. Okay, next to that, we have an environment variable. So any environment variable needed for the what process to run correctly. And third one is local resources. Okay, this includes all the necessary files and need to be what on the same machine before the process is launched. So that's why we are using jar files, correct? No. So we are using jar files, shared libraries. So any auxiliary data files, everything. The node manager will ensure these files are available. And next to that is security related tokens. So already I've discussed on this. So these are used to what authenticate the process with other services. Guys, this flexibility design allows the application master to launch a wide variety of tasks from a simple shell script to C, Java, Python process, or even fully fledged virtual machines. So this is what gives Yarn its power and also flexibility. Okay, so it is a huge step up, guys, from the Hadoop 1.0, where you are primarily limited to what Java-based MapReduce jobs. Now you can use languages and frameworks that are best suited for your specific problem. Okay, So here we have taken one examples, guys. So quickly, I will explain you this example. You try to understand this. So this is a slide is showing high level view of how resource manager sees the cluster. Okay, it has a global aggregated view of resource available across all the worker nodes. So what the diagram is showing? The diagram shows a master node. Look at here. The diagram shows the master node with a resource manager and multiple slave nodes. Okay. Understanding my point, guys? And each with the what? Node manager. Each worker node is having what? Node manager. And the resource manager keeps track of the what? Total resources available on the each slave, such as the what? Total memory and vCores. Okay, total memory and also vCores. Guys, a vCore is a virtual core. vCore is nothing but a virtual core, guys. Okay. So, and it is a what? Logical representation of your CPU core. Try to understand this. The ratio of vCores to physical cores can be configured. So you might set the what vCore to physical core ratio to be greater than 1 always. Try to understand this. So it should be always greater than 1. See, for example, for input output intensive job where the CPU is not the bottleneck, correct? No? And this diagram also shows how container is allocated on a slave node. Remember, the first container for an application is for the what? Application master. After that, application master negotiate for more container to run the actual task. Correct? No? The key takeaway here is that resource manager has a centralized global view of the cluster resources, which allows it to make informed scheduling decisions and prevent the resource contention. That is the main purpose of using this, guys. And we have one more example, that is containers and slave example. So this example you can go through by yourself, guys. So I don't want to explain you this because again and again I'm explaining you the same thing. I don't want to explain you this again, guys. So this is mapper and reducer task in container. Okay. So next to that we have, yes, this is very, very important one. I have to stress on this. So this is container executor. Once again, guys. Container executors. Okay, guys. So we know that the node manager is responsible for creating and managing containers. Correct? No? But how does it actually do that? The tool that the node manager uses is called as a container executor. Remember this, guys. The container executor is a component that is configured in yarn. See, look at here. Here we have a file name yarn site.xml. Okay, here this slide is showing. See, yarn.nodemanager.container executor.class. Correct? No. And sometime you can have Linux container executors also. Look at here. We have mentioned Linux container executors also. And we will be having Windows container executors also, guys. Understanding my point? So this shows the yarn is not limited to specific operating system. The container executor is a very important part of the security model. It uses set UID. Try to understand this. It uses set UID mechanism on the Linux to run the container process with the permission of the users who submitted the job. And this ensures that a user can only access their own files and not the files of other users. Furthermore, guys, yarn container executor also have Docker support. So this is the beauty. Okay, so Docker support. The Linux container executor we have here, right? Linux container executor can launch a yarn container either directly on the host machine or inside a Docker machine, Docker container. Okay, so this gives developer even more flexibility. And applications can specify which Docker image it wants to use for its container. This allows for better environment isolation and also portability, guys. Understanding? Okay, the container executors and its use of setuid and Docker are what make Yarn a multi-tenant, secure and flexible resource manager. Okay, you're all understanding this? Next, we have application enforcement mechanism. You can observe here. So how does the node manager enforce the resource limits for each container, such as CPU, memory, so on and so forth? The answer for this is Linux control groups, or we can call it as C groups. Okay, guys, maybe you have heard about this C group, right? C groups are the what Linux kernel feature that allows you to allocate resources among a collection of processors. Okay, think of them as a way to what? Containerize processors on a Linux machine. So C groups can be used to limit the process access to the CPU time, system memory, network bandwidth, and block input output. Okay, so this C group is very much similar to what process in few ways, guys. The very first one is they are hierarchical in nature. So you can have groups within a what groups actually. And second one is child groups inherit certain attributes from their parents group. Guys, so what you are understanding now? The node manager uses C groups to create a new control groups for each container it launches. Okay, it then sets the resource limits for that C groups based on the container specification. And the node manager then puts the container process inside that C group, and the Linux kernel enforces the resource limits. So this is a very powerful and efficient way to enforce resource isolation. Correct? No? It is a key part of the what? Yarn architecture that ensures that one misbehaving application does not bring down the entire cluster. So it is like a what sandbox for each task, and ensuring it cannot use more resources than it was allocated. Okay, so yes, that's all, guys. And if you have any doubt on this, you can ask me now. So till here everything is clear. So till here everything is clear. So if you have any doubt, please do ask me, guys. So till here, no doubts. You two have no doubts means I will move forward. So I want to talk more about resource manager scheduling. That is capacity scheduler. So till here everything is clear. Shall I get quick confirmation in chat box? I don't know where you people lost, guys. Am I boring you? No, I'm not getting any responses, guys. Are you all there, guys? Are you all there? No one is responding. Aditya, thank you, Aditya. What about others, Aditya? No one is responding in chat box. What happened to all? Ravi Kumar, where have you gone, man? Okay, thank you all, guys. So every time I have to wake up you people. Okay, fine, guys. So next, look at here, guys. So next we have few more topics, guys. Let me complete quickly. The resource manager scheduling, that is called as capacity scheduler. Guys, so far we have talked about the yarn, what is yarn is and its component. Now let us discuss how the resource manager actually makes decisions. This is important, right? So when multiple applications are submitting requests for containers, so which request gets satisfied first? Guys, this answer lies in schedulers concept. So yarn offers different schedulers. Okay, and the capacity scheduler is one of the most popular one. The core idea of the capacity scheduler is to put request into queues. Okay, the scheduler then picks the request from these queue based on a set of rules. The queues are typically set up with different capacities. Capacities are nothing but what? Resource shares, guys. Okay. And often hierarchical also. See, let me take one example to explain on this, guys. Okay, so you just take the example. A company might have different queue for different departments. Okay, you just imagine. So we have finance department. So we have sales department. So we have marketing department. Okay, we have taken 3 departments here. So each queue is given a certain percentage of the cluster resources. Understanding my point, guys? In my example, the Q1 has 10% of 10% of what? Cluster resources. And Q2 has 40% of your cluster resources. And third one is 50%. Okay. So here, how it works, guys? How it works? The very first thing we are talking about capacity reservation. I'm writing here. Capacity reservation. Guys, each queue has guaranteed minimum capacity. This ensures that even when the cluster is busy, a department's job will still get a certain amount of resources. So this provides strong isolation. Okay. And the second one, elasticity. Guys, if a queue is not using its full capacity, other queues can borrow the space capacity. Okay, this is called as elasticity. This ensures that the cluster is fully utilized. Am I right or wrong, guys? And third one is preemption. Third one is preemption. So if a Q1, see, look at here. If a Q1 is using some of Q2 space capacity and suddenly Q2 needs its capacity back, the resource manager can preempt container from Q1 to what? Give them back to the what? Q2. That is called as a preemption. Okay, it will stop executing there. It will go back to the what? Q1 and it will get back the what? All the resources. That is called as preemption. And next one is hierarchical queues. Hierarchical queues. What do you mean by this hierarchical queues? Guys, you can have queues within queues. That is called as hierarchical queues. Okay, for example, the finance queue can have higher priority queue and lower priority queue. Two. Okay, this can have two things, higher priority and also lower priority queue. Understanding my point, guys? The capacity scheduler is a great for multi-tenant environments where you want to partition system resources by some criteria. So like department wise or application type. So hope everyone understood what exactly this capacity scheduler is. And moving forward, guys, further I'm giving you more information on capacity scheduler. So let's dive deeper into what capacity scheduler now. This slide is completely giving a simple configuration snippet, but the concepts are what matters here. Okay, so you can set a minimum capacity for each queue. That already I've told you, right? Okay, this is the minimum percentage of resources that a queue is guaranteed to get. So even when the cluster is at max usage. Okay, so this is the isolation part, guys. Okay, and you can also set maximum capacity for each queue. So this is the maximum percentage of resources that a queue can use. So this provides the elasticity we discussed earlier, which is allowing a what queue to use unused resources from the other queues. So up to its max capacity, guys. Understanding my point? And guys, you can observe here. So this slide also shows an example of hierarchical QA. Hierarchical QA. Okay. So I think it is here. Yeah, I was talking about this. Hierarchical queue. You can observe here. So we have a root queue. Look at here. So we have a root queue. So this can have preference what sub queues. So which in turns can have low sub queues. Understanding my point, guys? The min share for root preferences low is minimum 20% to, see here, the minimum 20% of the 20% minimum share of root to preferences. So this allows for fine-grained resource management. Another very, very important aspect is, so user level allocations. User level allocations. So you can set minimum user percentage. Try to understand this. You can set minimum user percentage. So which is the what? Smallest amount of resources a single user can get across, get access to within a what queue actually. Not only this you can set, guys, you can set user limit factor also. User limit factor. Why we need user limit factor? Because we have to control the maximum resources a user can get, right? For that reason, we are going to use the user limit factors. And the very, very important thing what you have to understand here is, the key point to be noted here is the long-lived and short-lived containers. Guys, short-lived containers are nothing but your mapper task, correct? No? So these are all good for what? Balancing queue, because they finish quickly and free up the what resources. And what about long-lived containers? That are nothing but your Spark streaming jobs that can make it harder to balance the queues. So you need to what? Rely on preemption and limit factors to manage them. So, and one more very, very important thing what you have to understand here is, the capacity scheduler is a very powerful and configurable tool actually. So it is the what? Go-to scheduler for many enterprise environment. Understanding my point, guys? Yes or no? And I was talking about ordering policies, right? So here I mentioned few ordering policies. So even within a queue, a capacity scheduler needs to decide which job to run next. So this is handled by ordering policies. So we are going to handling by using this ordering policies. Okay, there are two main ordering policies we have here, guys. So one is called as FIFO, another one is called as fair ordering. FIFO and also fair ordering. What is FIFO? FIFO is nothing but first in, first out, right? First in, first out ordering. This is the simplest policy, guys. So jobs are ordered based on their arrival time. Okay, so here we are going to take the arrival time. Based on that, we are going to execute this. The first job used to be submitted gets the resources first. That's all. Then what are the pros and cons of this? The pros of this is it is simple and predictable. Correct? No? This policy is very simple. Ordering is very simple and also it is predictable. But there is a cons. There is a what? Disadvantages. A large applications can block other smaller application. So this is leading to a what? A user discontent. Correct? No? There is no preemption within a queue. So a short job might have to wait for the what? Long time behind a big one actually. So to overcome this, so we have one more policy that is called as fair ordering. So this is more modern and also popular approach. We all know about this. The idea is to give resources to the request that have a what smallest resource allocation so far. The scheduler will try to get all the application started as soon as possible. That is your fair ordering. Then what are the pros and cons of this? Guys, the pros are it works well when there is a what good container churn. So the meaning of this is containers are finishing quickly and freeing up the what resources. It's much fairer and prevents smaller jobs from being started. Guys, the choice of ordering policy depends on your workload, guys. So if you have many small jobs, and a few larger ones. So fair ordering is better choice. If you have jobs, okay, with what similar size means, then you go for FIFO. That might be what sufficient for that. And the scheduler also has a what way to map users and groups to specific queues. So this can be configured to put jobs from a what specific user or group into a designated users. So finally, we can also use priority. Okay, along with this, so we can also use priority, guys. Okay, so we can also use priority. So that influence which queue gets a new request. If QA has higher priority, so it will get new request even if it resources utilization is high. So this is very powerful set of tools to fine tune your cluster performance. Okay, so resource scheduling, fair scheduler, I just explained you. Priority concept also I just explained you. Suppose you need more information on fair schedulers means you just look at here. So this is very much contrast to your capacity scheduler. So which focuses on capacity. The fair scheduler focuses on ensuring that all the applications get a fair share of the cluster resources over a time. Understanding my point, guys? So instead of min and max percentages, the fair scheduler uses weights here. So this is going to use weights concept. Okay, a weight is a what? Measure of what a queue consider its fair share, and total of weights does not need to add up to 100%. Say for example, if QA has a weight of 1, QB has a weight of 2, QB will get what? Twice as many resources as a QA. That's it. Okay, so here we have some key aspects of the fair schedulers. One is fair share. The very first one is fair share. Fair share. What is the meaning of this fair share, guys? What is the meaning of this fair share? Guys, it ensures that all the apps get a what fair share of the cluster. That's all. On an average. So this works well when a short jobs are start and long jobs get to finish without undue delay. That is fair share concept. Okay. And no capacity min max. That is the second one. No capacity min max. What do you mean by that, guys? It does not have the concept of min capacity and max capacity. So instead, it uses a single weight for each and every queue. Understanding? And next we have one more that is called as apps. So app level fairness. Okay, what do you mean by app level fairness? So it also works at the what application level. You can assign a weight to an application to influence its fair share. And finally, we have hierarchical. Okay, finally we have hierarchical. That is like the what capacitor scheduler. Queues can be what organized hierarchically. Guys, what you want you have to understand here. The fair scheduler is a more dynamic and flexible scheduler. So often preferred for our clusters with diverse workloads and where you want to give a fair chance to all the jobs. Okay, so we have taken one small example on this. Okay, this is the beautiful example they have taken here. So let's say we have 3 queues. So already I've told you, right? So one for marketing and another one for sales and third one for data science. So marketing has weights 3. It is nothing but 15%. Sales has a weight of 4. It is nothing but 20%. And the data science has a weight of 30. Okay, then what is the total weight, guys? Total weight is equal to 3 plus 4 plus 13, right? That is equals to 20. So this means that marketing will get 3 by 20. That is equal to 15%. Okay, that is 15% of the resources. The meaning of that is 15% of the resources. And sales will get, so 4 by 20. So it is equals to 20%. And data science will get 13 by 20. It is nothing but 65% of resources. So this is their fair share. The key thing to remember is that you can change these weights to change the fair share. So this gives you a lot of flexibility to adapt to changing business needs. And guys, one more very important thing is you can also set a weight of 0 for a queue. The meaning of this is, so it will only get resources on a best effort basis. It does not have a guaranteed fair share, but will get what is remaining if there is spare capacity. Understanding my point, guys? The fair scheduler provides a simpler way to manage resource allocations than the capacitor scheduler. Okay, you just set the weights. The scheduler takes care of ensuring the fairness. Okay, so here, next slide, I'm talking about preemption. So preemption concept already I've explained you, right? So what do you mean by preemption? So preemption is a very important concept in both capacity and also fair scheduler. So it is the ability of what scheduler to stop a running task to get its resources to the higher priority task. That's it. Okay, so let's imagine a scenario in a what fair scheduler. I'm taking the scenario with respect to your fair scheduler. Okay, first I'm taking application A. Application A is running in a Q1 and it is using some of the spare capacity from Q2. Try to understand this. Suddenly, new applications are submitted to Q2. Now it needs the minimum capacity back. Right, guys, without preemption, the new jobs in Q2 would have to what wait, right, until the containers used by application A. But with preemption, Q2 can reclaim its minimum capacity immediately. The scheduler will kill some of the running tasks from application A to free up the resources for Q2. So this is called as preemption. So here, how preemption works, guys? So try to understand this. How preemption works. Understand these points, very important. The scheduler tries to kill the younger or less progressed applications first. So here I've given the very first point. And it prefers to kill reducers over mappers because mappers might have already done a lot of work. And killing them would mean a what significant loss of work, no? Are you getting my point, guys? Guys, preemption is not a silver bullet. Okay, it is not a silver bullet though. Okay, so it will only happen if it can fulfill the entire allocation request. It won't kill a task for a what? Partial request. Try to understand this. Okay, so here I'm showing you few configurations on what? Preemption. Okay, so fair share preemption timeout. See, we have taken. So fair share preemption timeout we have taken as 60 seconds. And fair share preemption threshold time also we have taken here. Look at here, guys. Okay, so guys, preemption is powerful tool for ensuring that your cluster is used efficiently and that high priority jobs gets the resources they need. Okay, so now we have few informations on log files and a few informations on yarn command. So I'm going to explain you quickly, guys. Guys, debugging a distributed applications can be nightmare if you cannot access the log file. Fortunately, Yarn has a robust log management system built in, unlike your Hadoop 1.0. Okay, where logs were scattered across different nodes and difficult to access, guys. So Yarn makes sure that the local logs from each task are moved to the file system like what HDF is. The node manager is responsible for this, guys. It collects the logs from the container it runs and moves them to a what central configurable locations on HDFS. So this is a huge improvement. So you can now use yarn command or yarn UI to easily retrieve these logs. So you can get logs at the application level or even for the specific task. So this makes debugging much easier. So even guys at the time of what real-time execution, so you can use some yarn commands to what configure the mistakes. Okay, that I will show you in the next slide. See, look at here. Here we have taken some information. You can observe here. The very first one, what I'm talking about. So yarn app list, look at here. I have mentioned yarn app hyphen list also you can take. Let me write here. So these are the codes I have run used in my application. Yarn app and then hyphen list and then you take hyphen app states. App states running continuously, guys, in a single line. So this is a very useful command, guys. Okay, so it tells you which applications are currently running on the cluster. So this you can check after running your Java means what mapper and reducer code. And we have one more, that is yarn app stop. Yarn app stop. Stop with hyphen. And you have to mention application ID here. Application ID. So you can use this to what? Stop the running application using its application ID. And next to that, you have commands on update priority also. See here, you have yarn stop. So you have a commands on update priority also. So this here, see here also you have to mention application ID. So this allows you to change the priority of the running applications. And one more we have here. So this already I've shown you, right? So one more we have here, yarn apps application ID. So this is the command you will use to what? Debug. So it will get all the logs of the specific applications. And you have one more, guys, that is on jar. Yes, it is here, it is mentioned. So this command. So yarn jar, and then you can mention jar file name, and you can mention application main class name and also arguments. So this is the command you will use to submit a Java MapReduce job to the yarn. Okay, guys, all these commands, see, only I mentioned few commands here. Okay, so all these commands are available in your mapper and reducer environment. The yarn CLI is a powerful tool for managing and monitoring your jobs, guys. Okay, so that's all about the concept comes in session 7, guys. So if you have any doubt on this, please do ask me. Sir, yarn is installed. Which Hadoop binary installation time? With the Hadoop, okay. He is asking something. Need to install it separately. So which version of which version you have installed? Have you installed Hadoop 2 or Hadoop 1? Pradeep. Okay, so you are installing Hadoop 2.2 plus means then definitely by default it will get yarn. Okay, better you install Hadoop 3 point something, so you'll not get many problems. Okay, so otherwise, see, already we have given access to your virtual lab, so it is completely installed. So it is ready with Hadoop MapReduce and along with that Pig and Hive. Okay, you people can use. Okay, because see, after the completion of your examination, so I'm going to give you assignment, guys. So because of that reason, so every tools are ready to use now. Okay, so already see, I have put some program on your Tuxila, right? So you just go through that program. So that will be what giving you idea how you are going to get your assignments. Okay. Is this clear? Is this clear to everyone? So till now, everything is clear, guys. So can you give brief introduction about exams, sir? So at the end, okay, Ravi. So wait till end. What brief information you want on examination? So we can discuss it later. Okay. So if you have any questions on today's session, please do ask me first. Okay. Yes, guys, no questions means we will move forward. Guys, this is the concept of session 8. In session 8, guys, we are planning to introduce 3 different technologies. So one is HBase. These are all completely practical oriented, guys. The very first one is HBase, and second one is PIG, and third one is Hive. We all know, right? What is HBase, what is PIG, what is Hive? So anybody heard about PIG, Hive, and HBase? Can you give one line? Okay, Jyoti, break for 5 minutes. Actually, I'm not extending class today. So if I give you break, then I will extend class today. Is it okay, Jyoti? Is it okay for you people? So if I give you 5 minutes or 10 minutes break means, so after this, I'm going to extend the class. Now Jyoti is saying no. Okay, yes. So what for HBase, what for PIG, what for Hive, guys? How many of them heard? HBase is a NoSQL database that provides random access to data stored in HDFS. Yes or no? What about HBase first? First, tell me HBase, guys. Come one by one. So no, HBase is one of the what? Famous NoSQL database, correct? No. So which is giving an access to the data stored on your HDFS. Am I right or wrong, guys? And what about PIG? Yes, one of your friend told. So PIG is high-level scripting language that makes it easier to write mapper reducer job. So till now for mapper, we have written separate program, right? Scheduler, we have written separate program, right? So in PIG, no need to write mapper code and also reducer code. So in background, it will take mapper program automatically and it will run the code. So that is your PIG actually. So it is high level scripting language. And what about Hive, guys? So what about Hive? Is it database? Is it database? Hive? Yes or no? Guys, actually Hive is very good answer. Very good answer from Aditya. So guys, Hive is a data warehousing system that allows you to use SQL-like queries and data in HDFS. So SQL-like databases in HDFS, guys. So these are the 3 tools we are discussing in today's session. Guys, these are all part of a larger Hadoop ecosystem, and they provide easier and more flexible ways to work with big data. Okay. And they abstract away the what complexity of writing native MapReduce jobs and make the platform accessible to a wider range of users. So from data analysts to business intelligent professionals, for each and everyone. So it is providing a platform. Okay. And one more thing, guys, what we can do now. So we have left with only 20 minutes. So can we do one thing? Can we start directly with the PIG concept? So is it okay for you all? So I'm going to skip HBase concept. I'm not going to cover HBase, Hive, and PIG in today's session. So let me try to complete at least PIG. Okay. So shall we start with PIG? Shall we jump from HBase to PIG directly? So if you are permitting, I will start, guys. Otherwise, I will start with HBase. But no, don't worry, guys. I'm not going to include questions on HBase, Hive, and PIG. I'm not going to include any questions on PIG, Hive, and HBase. That is the good news from my end. Is it okay for you all, guys? I will go very slowly to explain PIG concept. So is it okay for you all? Guys, let me start with the PIG concept. Yes, thank you for your confirmations, guys. Guys, if you are a data analyst or a data scientist, so who is not Java programmer, and writing MapReduce job can be a pain, then PIG solves this problem, guys. Okay, understanding my point, guys? You're all understanding. How many of them How many of them don't know anything about Java programming? Can you raise your hands? So I have so many students now. How many of them having no knowledge on Java programming? You just type me and chat box, guys. Okay, so only 3 people. Okay. So how many of them are facing problem with MapReduce? Yes, only basic. No problem. This is for you people, guys. How many of them what worrying about MapReduce code? Many of them, right? So just see in what big data class I have taught you the MapReduce concept. Guys, for you people, the big tool. The big tool for you people, guys. That's all. It is a high level scripting language that allows you to express your data flow in a much simpler way. Okay, you write a what pig script and pig engine automatically compiles it into what series of MapReduce jobs. It is a fantastic tool for data transformations and also ETL, guys. What is ETL? What is ETL? Can anyone tell me? It is a very good task for ETL. That's all. That's all I can say about pig. Okay, yes, thank you. Now let us start with the pig concept directly. So I'm jumping HBase. I'm not going to teach you HBase now. So without teaching HBase, I'm jumping directly into pig concept. I will come back to HBase later, guys. So it is not yet installed. So only pig and hive is ready on your system. So that's why I'm explaining you pig concept today. Guys, here I'm showing you pig introduction. Okay, I'm showing you pig introduction. Okay, where is it? Yes, it is here. Guys, actually, already I mentioned, right? So pig is a high-level data flow language for parallel computations. Okay, so guys, the very first point of what it is mentioned here is, so pig is high-level scripting language. Okay, guys, its primary use case is for data transformations and analysis. That's all. It is a great tool for data analysts who want to work with large data sets without having to write complex MapReduce code. And one more very, very important thing is it runs without Hadoop, and it runs without, with Hadoop actually. It runs without Hadoop and it runs with Hadoop. Guys, it runs on Hadoop means a pig script is compiled into a series of MapReduce jobs that runs on a Hadoop cluster. That is the mean. And one more very, very important thing is it abstracts the complexity. So pig hides the complexity of writing MapReduce job. And it is allowing you to focus on data flow and the business logic. That's all, guys. Then why would you use pig, guys? Correct, no? That question will come to our mind, right? Why we have to use this? The very first question is, very first answer for this is productivity. Productivity. Guys, you can write a pig script in a few lines. That would take hundreds of lines of Java MapReduce code. This makes you much more productive. Is it interesting, guys? And second one is, it is interactive process. Sorry, not interactive. It is iterative process. Iterative processing. What is the meaning of iterative processing, guys? We have discussed in the previous session, right? So it is a great for iterative processing where you need to run a series of jobs to get your final result. And finally, guys, data exploration. So it is a great tool for exploring data and performing ad hoc analysis. Guys, you just think pig as a what scripting language for big data. You write a script and the pig engine translate it into detailed execution plan that leverages the power of Hadoop. The key understanding Pig is to what? Think about the data flow. You load the data, apply a series of transformations, and then store the result. Understanding my point, guys? That's all. That's all about Pig concept. Very simple. And you can see here, I will show you this later. I will show you all these commands later. Before this, so I want to explain you one more thing. So Pig Latin language. So many of them are say about what Pig Latin language. Guys, Pig has its own scripting language. That scripting language is called as Pig Latin. Okay. I will show you the example of word count later. Okay, I will show you the example of word count later. Maybe it is there or not, I don't know. Sort. We have program and sort. No, directly they have jumped here. No problem, guys. Listen to me carefully. Okay, you can take the example of what? Word count. I will show you that example later for your explanations. Otherwise, I will mail you guys. No need to worry about that. Okay, you just take the keyword hello word of big data. Okay, you just take the word hello word of big data. Okay, one second, guys. Okay, guys, let's break down the script line by line. So very first thing is we have to write a command to load the data from the file and assign it to the alias of any file, guys. Okay, otherwise I will do one thing. Let me show you with the example. Is it okay if I show with the examples? Okay, I'll do one thing, guys. Examples I will show you later. This Latin program I will explain you later. So before that, go through the architecture of Pig. Guys, this slide will give you the Pig architecture. You can see here, it is showing in a diagrammatic representation. So it is showing with the what different stages. Okay, the very first stage you can observe here. The very first stage is Pig Latin script. So this is the script we write. Okay, so like the word count example, anything. Okay, and next to that we have a parser. Look at here, you can observe here. So next to that we have a parser. The Pig engine takes the script and parses it. It checks for syntax error and create logical plans, everything. Understanding my point, guys? And you can ask me, sir, what is that logical plan? Okay, what is that logical plan? Let me write here. Guys, this is the representation of data flow in the script. That's it. So it is the graph where the nodes are the operators. Say, for example, we are going to use load, right? So we are going to use group, right? So we are going to use store, right? So these are all called as logical plans. Okay, and these are the edges. Edges are the what? Data here. And next to that, we have an optimizer. So this is a very important part of the Pig engine. It takes the logical plan and optimizes it. And it looks for ways to make the what execution more efficient. See, for example, it might reorder some operations or use a combiner if possible. That is the main job of optimizer. And next to that, so we have one more that is called as physical plan. Okay, next to that, we have one more that is called as a physical plan. Okay, after this, you have one more that is not mentioned here. Okay, like your logical plan. So physical plan means the optimizer generates a physical plan. So which is the what graph of map producer's job. So each job is the node in the graph and the edges represent the data flow between them actually. Okay, so after that we have map reduce execution. So we have compiler also. See here. So we have compiler. Compiler generates MR jobs and optimizes the execution order. And next to that we have an execution engine or map reduce execution. So this is a kind of what physical plan. See here. Sorry, I'm getting physical plan from optimizers and it will go to compiler, right? So after that, again, the same physical plan will be what receiving by this execution engine. And this is going to what executed by the Hadoop MapReduce engine. Okay, look at here. So we have a MapReduce engine here. By using this, we are going to execute the code. Guys, this architecture is very similar to how a relational database works. Okay, so it writes a SQL query. A query optimizer creates an execution plan and query executor runs it, right? The same way we have written here. That's it. So little bit more stages we have here. And Pig brings this familiar concept to the world of big data. And what is the key takeaway? Guys, Pig provides a layer of abstraction that makes it much easier to work with Hadoop. And you write a simple script and the Pig engine handles all the complexities of what parallelizing your job and running it on cluster. Very simple, guys. So next to that, we have few data models. These are all the data models we are going to use there. So this and all I will explain you later. So before that, let me show you a few examples on Pig, how to work on this. Okay. With this, I'm going to stop today's session. Let me show you guys once again. Why my camera is not working? Okay. Okay. So guys, here we have started with Node. Oh my God, I got an error here. So let me reconnect. It is installed on your master system, guys. It is already installed on your master system. You just open your master system and it is cloud. Okay. So here, guys, the very first thing is, once again, guys, let me look at few commands. I will post all the commands on your system, guys. No need to worry. Okay. You can check all the commands after this class. Okay. So the very first command, guys, suppose you are working on Hadoop system means. Okay, you are working on Hadoop system means, then you have to give pig minus x mapper. So this is the command you have to give. Otherwise, you are working on local system means, then you have to give pig minus x local. This is the very first command you have to use in pig. Okay, I will show you everything already I've worked. Okay, sudo power off they have done. Okay, once again, guys, I will show you each and every commands in detail. So initially, as I told, you are starting with pigments. You can check with the version of pig also, guys. So how to check version of the pig? Pig space version. So this will give you the version of your pig. This is the very first command you can check on your system. And suppose, as I told, guys, you are starting your pig script on local machine means. So then you have to give pig space minus x followed by local. This is the command you have to type, guys. So once you are typing this command, so it will redirect you people to grunt actually. So look at here, it is showing grunt prompt, right? So it will take you into the grunt prompt. Otherwise, to come out of it, you have to type quit command. So once you are using quit command, it will come out of it. So this is one way of entering into pig and also coming out of the pig. Okay. And yes, let me check whether the database is available or not. So here, yes, I have, I have a database here. Cat, let me check with this. What is there in student.txt. Look at here, guys, what database we have inside this. So we have 3 columns, right? So one is name, first one is name, second one is age, 21, and third one is department, computer science department. So we have 3 lines of data here.
The same data I'm taking here for the execution, guys. Okay. So let me check with my HDFS also. HDFS, DFS minus LS, LA space slash. I think I've taken folder name user. Inside user, I've taken one more folder name, that is input. So let me check whether it is present or not. Okay. Okay. What happened to this? No such directory. Okay. I'll do one thing. Let me remove this. Okay. Nothing is there. Then how to load this, guys? We have to load this file, right? HDFS, DFS, put we have to use, right? So we have to use the command put. Before that, we have to create a directory then. Let me check once whether it is present or not. Actually, I've created yesterday everything to show you people, but someone is removed. So localhost. Colon 9870. Nothing. Okay, okay. Something is there here. User, it is already there, no? User input. See, input, it is there. So inside input, nothing is there. Okay, but this directory is already there. Then what I'm going to do? So I'm going to upload this directly to the folder. Put what is the file name? File name is student dot, right? Student.txt. This file I'm moving to slash user slash input folder. Okay, now it is loaded, guys. Now it is jumped. So we have uploaded. Look at here. So student.txt is uploaded to the HDFS. Now I can use this to work on pick commands. Okay, so let's come back to here. So now what we have to do? So your data set is ready. So once your data set is ready, now we have to work with pick commands. So guys, what I'm going to do, I'm going to show you in local commands now. Otherwise, I'm going to show you with the Hadoop commands, guys. Okay, directly I will show you with the Hadoop commands. Once again. So for that, I should know the path of your input file. It is already uploaded, then path is not required. But still, guys, wait a minute. PWD. Okay, let me go with this. The very first command is students. This is the command equals to load. Load is the command we are using here. So it will load a file into this one. Okay, file. Not sorry. You should give it in small letter. So file colon slash slash. What is the path here? So we have to take this path. Copy this and paste it here. One second, guys. Okay, and inside this we have student.txt, right? Student.txt file, and close the single quote. And next to that, look at here, guys. This is very, very important one. I am taking using command, and immediate to that we have pig storage. So this is what we have to use here to store this into pig. So pig storage, and it is comma separated, right? So we have to mention delimiter. Since it is CSV file, otherwise text file, it is separated by comma, means we have to mention comma, and then as, and we have to mention schema. So what is the schema we are using here? I have shown you, right, the file name. So look at the file name. What and all content we have here? So we have name. Okay, we have name here, and then 21, that is age, and third one is department. Once again, guys, it is disconnected. Okay, then what is the syntax we have to take, guys? The very first one is I have to type name, and then data type we are using char array. This I will explain you later. That I was showing you, right? So char array I'm taking, comma. What is the next data we have taken? We have taken age, right? Second one is age. That is the variable name. And this is integer data. I'm taking this as an integer, comma. And third one I've taken as department. So DEPT. I can call it as department. And then it is also character array. So this is character array. So this is the data type I've taken. So you have to write this complete schema and then semicolon is important. So this command will load this student.txt file to this format. Okay, then press enter. Okay, there is an error where I did mistake, guys. Syntax error near unexpected token open brace. Where I have opened. Hmm. So home, cloud, desktop, student.txt, everything perfect, no? One second, guys. Okay, guys, I'll do one thing. Okay, all these commands I will show in the next class. Is it okay for you all, guys? Anyway, I'm not giving all these commands to your examination. Okay, why? What happened? Brace is not closed properly now. What? I have closed it, no? I have closed it, right? But I don't know why I'm getting error there. See, here I've opened it, and here I've closed it. Here also I've opened it. Here I've closed it. But still I'm getting error. No problem, guys. This we can discuss later. All the comments I will work and I will send it to you guys. You better work on your system. Otherwise, see, once I'm getting an error, then to solve that, it will take so much of time. So is it okay for you all, guys? So I will work with all the pick commands and one case study I'm going to give you all. Okay. But there is no much concept to discuss on pick, guys. So we have to left with only data types that we can discuss later. Okay. Sir, up to which session midterm syllabus? Till year, Gautam. Okay, till date. So you are going to get all the topics. No HBase, no Hive, no pig. Yes, yes, Jyoti. Yes, guys. So anything you want to ask, guys. So if you have any question on today's session, please do ask me, sir. Will code be there in midsum? Yes. So mapper and reducer code, mapper and reducer architecture.
So everything will be there in your examination. And you can go through the Taxila. See, in Taxila, I have uploaded all, guys. You have a separate MapReduce code and MapReduce examples. See, module 7. You click on module 7. So you are going to get one more folder here. You download it. So here I have executed all running program. So written in Python. Okay. Sir, what type of question can we expect in EC2? Are going to have any commands based question? Amanvita, I'm not understanding. What do you mean by command based? What do you mean by command based? Yes, Ravi Kumar, is it working? Is it working for you? Okay, so you have removed one backslash, is it? Let me copy this. This must be assigned to a variable. Students. Okay. Name character array, age character array, department character array. Spelling is correct now. Character array. I did mistake here only, guys. See, here only I did mistake. Character array. So instead of character array, I have written something else. Correct? No. See, here I've done a mistake. Okay, is it mistake? CHARRARAY. CHARARRAY. So in my statement, it is correct now. So Ravi, you have done mistake here. ARRAY. No, here also we are getting syntax error. So I'll check it, guys. No need to worry about this now. Okay. No problem, guys. This we can discuss later. Sir, what is the ratio of code? Guys, actually, I have not think about ratio of code. Most of the questions I have given from case studies. Okay, so maximum questions on case study and also scenario based, not codes. So only few percentage of codes you are going to get in the examinations. And yes, numerical problems, more numerical problems. Unmute everyone. Yes, it is unmuted, guys. Guys, it is unmuted. If anybody want to talk, you can talk to me. Yes, Ajit. Ajit.
Yes, sir. Nothing. I just by mistake I raised the hand.
Oh, okay, no problem. Yes, guys. Ravi Kumar. Ravi Kumar, I have unmuted.
No, Gautam, can you hear me?
Yes, Ravi Kumar, talk to
Ah, yeah,
me.
thank you. Yeah, Gautam, sir,
Yes.
actually, mine is just now I scheduled that 4 exams for each week. It is like how many hours that exam and uh, so up to what syllabus the exam and all, where I can see.
Ravi Kumar, you're asking this question for me.
Yeah,
See, I'm telling you my syllabus, right?
yes.
See, till today. So whatever I've taught, everything will be there in your examination.
Okay, can you share your screen and show me in the chapter wise so that we can prepare? How
No,
the
it is
exam? It is a descriptive and objective, or else how it is?
no, it is not objective, Ravi Kumar. It is descriptive. Either you can
Okay.
use your system, otherwise you can use pen and paper to write the examination.
It is
So
in exam
regarding this, they
center
have
only,
given
right?
already informations, right?
No,
You
no, no.
have to go to
Actually,
your nearest examination center and
yeah,
then you have to
yeah.
write your examination. And even they have given practice to you people, right? So how to take up
Actually,
an examination?
yeah, yeah. Actually, I'm not there at the time. I'm not able to join the call at the time. I'm so due to some personal reason.
No
That's
issue.
why.
You can talk to your friends. Otherwise, maybe yes, recording is available. You just go through
Okay.
that. They are going to
Okay.
provide you all the recordings.
Okay. How much time the exam and all?
It is 2 hours. It is 2 hours
2 hours.
examination
Okay.
for
That is
30
the
minutes.
okay. That is a midterm exam means is it mandatory to write or if you skip any issue?
Yes, it is mandatory. See, out of 100 marks, see, the complete big data is for 100 marks. So in 100
Okay.
marks, 30 marks for your EC1. So EC1 means it is quiz 1, quiz 2, and also one assignment. And
Okay.
EC2 for 30%, that is 30 marks. And EC3, 40%.
Okay.
So each and
So
every
that is
examination we are
semester
going to
exam.
consider.
That is final semester exam or a midterm
This
only
is midterm. See, after
midterm.
see after completion of 16 session, you will be having one more exam. That is comprehensive exam. So that is for
Okay.
40%, 40 marks.
Okay. That is the main exam we can consider.
No, it is not like main exam. Every exams are main for you. I told you, no.
Oh, why?
So we
No, no,
have
no. Why?
divided 100
Because
marks into three parts.
no, no, no. Actually, my graduation, my PG completed 20 years back. After that, I'm writing.
Okay.
So that's why just I want to know
No
this
problem. No
exam.
problem.
Yeah, this mid exam and that after that you have one more for the first year first semester exams. That is these exams also considered as the main marks passing.
Yes, Ravi Kumar, you can look at here. See, in
Okay,
handouts, we have mentioned clearly. See, is it
okay.
visible?
No, no, no. For me, it is not visible.
1 second. Let me share my screen. I've stopped sharing my
Yeah,
system.
show me
System.
one exam so that remaining I can.
Second. I am not able to. So it is hand. Can someone share that examinations details? Yeah, now it is enabled. Is it visible now, Ravi?
No, sir.
Now?
Yeah, yes, no.
Yes. Look at here, Ravi Kumar. See, we
Yeah,
have
just a
divided
second.
your 100 marks into three parts. So the first one is EC1. So 10
Okay.
marks per quiz, 20 marks for your assignment. So assignment I'm going to give you later. So quiz one already you have taken. Quiz two you have to take. So quiz one 5 marks, quiz two 5 marks, 10 marks totally, and
Here,
assignment 20 marks.
sorry to
That I will give
interrupt.
you later. And
Yeah,
this is EC2. EC2 means midterm examination. So it is closed
okay,
book exam. Okay.
okay,
And it is the weightage of this is 30%. And hours also we have mentioned here. Date also we have
okay,
mentioned here.
okay,
Okay. And one more thing, look at here. EC1, EC2, everything we have mentioned at the bottom. Syllabus for mid-semester exam, close book. Topics in
mm,
contact session 1 to 8.
yeah, yeah. And one
Syllabus
thing,
also mentioned here.
Yeah, I have. Can I talk now?
Yes, yes,
Yeah,
Ravi.
in EC one, out of four, one we missed it. Three we wrote it because one is time expired. So we drop an email to respective person. They are not yet enabled it. So that means again we should not able to write, right?
Which exam you're talking about?
That
Can you tell me
is
the
EC one
Can you tell me the subject?
subject. Yeah, EC one.
No, EC1 is there for all.
Okay, that is one time up. That's what it is shown.
Now, which subject? It is not on
One,
big data, right? See, for big
one
data
second.
also you have the same. For other subjects also you have the same.
Okay. Uh, One second, give me. I'm sharing my screen.
I think you cannot share your
I
anything.
cannot. Yeah,
You
yeah.
can. That option is
Uh,
not there.
okay. Actually, I scheduled these exams and all.
Now, which subject, Ravi Kumar? You tell me the subject name.
Yeah, just a second. I will.